Hello, everyone. Welcome to Swimm's webinar on Backfill legacy code documentation automatically. My name is Gilad Navot. I'm the CPO of Swimm and a co-founder. With me here is Omer Rosenbaum, also a co-founder and the CTO. Without further ado, let's talk about the agenda. So I will start by talking a bit about legacy code, which is the reason you're here for. And then Omer will talk about the challenges of harnessing Gen AI to generate automatic documentation for legacy code, specifically for ancient languages. And then he will talk a bit about our approach and the technical approach that the technical solution that we chose. And finally, I will talk about the full solution, and I will show you some examples of what we did. At the end, there will be a Q&A session. If you have any question, don't forget to write it in the chat. You can do it through the webinar itself. So let's talk about large project lifecycle. So code projects are being born. They are very cute and small. They have a few lines of code, and all of the developers know exactly what's going on there. They know almost the entire project. I chose this brain emoji to represent developers because I want to talk about this organic manifestation of code, or this mental model that developers have of the code base. As a former developer, I remember once I wrote code or I solved a bug, this code went with me home, what I was eating, what I went to sleep, in the bathroom. It just kept living in my brain. So this is very good for the company because the time it takes to understand the code is not crucial. And most of the time is being spent actually solving the tasks because there are large features to implement and the code base was just born. When the code base is growing, more and more developers are being added to the project. More lines of code are being added to the project, and it becomes impossible for one developer to know all the code in the code base. So silos are being formed, which means more time. It takes more time to understand the code because usually you need to have that person that knows this part of the code. And if he's not available or she's not available, you'll need to wait. So this is when understanding the code becomes more important. As the project matures, and there are places in the code base that are robust and stable because all of the bugs were squashed there, less and less developers it keeps a mental model of that code base. So you start to have this legacy patches in your project. And of course, some developers leave, some developers retire, and some developers even, they think they have a mental model of a part of the code base, but when they actually say it to someone, they realize that it was refactored not long ago, or that it's no longer the case. So mental models decay and they're getting out of date. And then projects, when they're mature and they actually bring a lot of money to the company, developers move to other more urgent projects because this is stable, this is working, and very few developers keep the mental model of this project. And sometimes it even looks like this. So we know some clients that no one at the company knows what the code base is doing, and this code base is actually in production, and it's working and it's earning money. This stage, this is where understanding the code takes most of the time, and this is a real pain and a real business risk, because every time something is happening in the code, it takes a lot of time to remediate or fix any of the issues that arise. Or if you want to generate a new to create a new feature, will also take a lot of time. At this point, you have two options: either to modernize the code base and, like the Phoenix, reborn and just like start to have a baby project again with a lot of developers with modern frameworks, and then have again a lot of mental models knowing the project. Or you can just don't risk it and just maintain the code base as is. Either way, you still need to rebuild these mental models for your developers to be able to maintain it or modernize it. We knew some customers that actually went through several cycles like this. So they modernized, and then it's legacy again, and then they need to modernize again. So it's kind of a loop if it's a successful project. So what it means to rebuild the mental model. So what is there? What might be there? So first of all, there's this overview of where's what. I know where it is implemented. I have a visual of in which folder it is, in which repository it is, if it's microservices. What are the main components? What each component is in charge of? What are some interesting flows or complex flows that I know in the past we had tons of bugs there. And I know that I want to stay away from those, or I need someone special to tackle bugs there. And of course, the business logic flows. Like I know the flow of our product, so I know that if the client is clicking this button, then it calls this function, and then this happens. So all of this is like parts of this mental model that we need to rebuild now for this legacy code, this cold code that no one keeps live in their head. How do you do that? How do developers do that? So first, you need to get this overview of the project. So I need to explain what is this project about, where is everything, and then I need to take you for a walk through the code and show you some examples. This is where we do this, and this is how we do that, and this is how you add a new X, and this is how you sanitize input from the user, and such and such. And then I need to be able to control the level of details, because if I need to drill down and find the bug, I need to really understand what's going on. But if I'm too overwhelmed and I want to zoom out, I need to be able to zoom out and understand what's going on generally. So we envision this thing and we say, okay, how many docs do we want to generate? Do we want to document each line in the code base? Do we want to just like talk about the general topics of the code base? So we envisioned like something like covering 60% of the repository, finding the most important flows, the most important classes, and then giving some like overview of what is this repository about? What are the connections between those components, dependencies, imports, stuff like that, and then going through each and every component and say something short about it, and attaching the documents that are relevant to this component. And then trying to mimic the way a mentor or a senior developer explains code to someone new. We created this, we thought about this walkthrough documentation, that it's like, you see the text, you see some diagrams, like high level, and then we talk about a part, and then we show examples, and when we add some text more, and we're like, this is the conversation that you have with a senior developer that explains parts of the code. It is also very important that this thing would be within your workflow, meaning in your IDE. Developers do not like to context switch, and they want to be able to read this document and jump rather quickly to the actual code and go back into the doc to keep on reading. So we wanted it to also be code coupled. So what documents do we need? We need an overview doc. We need to go over and discover the logical components of the repository. We need to understand which flows are important there. So all of this vision, Omer and I, we go a long way back. So we have a well-defined API. So I went to Omer with this, and I asked him to research and to make this. So Omer will talk a bit about this journey of the challenges of using that.
Yeah, so hi everyone. As Gilad said, we have a well-defined API, and Gilad talked to me about this vision of having all of these documents created for a repository. And we've been tackling this problem of code understanding and in general, legacy code in particular, for the past few years running Swimm. And specifically, with the rise of LLMs, we thought there might be an opportunity here that might be added to everything we've learned even before LLMs became such a mainstream kind of technology. So I would like to share with you some of the challenges we had and then our current approach. one thought that we had, and we also heard from people, is that AI might understand the code. And you have a code base, you have an LLM with a very large context window, just send it the code, it understands the code, let's go from there. So let's try to break this a bit. Given a hypothesis that the LLMs can do a lot of the hard work for us, what do we really want? So Gilad mentioned different types of documents, and for each of those, me and the team, of course, worked a lot to produce the highest quality documents we could. Since this is not a whole course or something like that, I would like to give you a taste of something. So I chose to focus on flows documents. We know that flows in a code base is one of the things that people want to start with when they are new to a code base. And also when they debug something, usually they want to understand the flow, the data flow, the logical flow of the code. So I'd like to focus on that. So let's think about giving an LLM a task of creating docs about flows. So basically, we are asking the LLM to do two things. Find the most interesting flows first, because we don't want to document every single flow in a huge repository. And then for each interesting flow, document that flow. Okay, that sounds clear. So let's start with the first one. How do we find the most interesting flows? So logically, what do we send to the LLM? I mean, if you work with LLMs, you know, it's a query response model, right? You ask a question or send a prompt, you get a response. So do we send like, here is the code, what are the important flows? That's not really a question that LLMs are adept at answering. And to answer that, the LLM would need to do basically two things. First, to find all the flows in the code. And second, decide which flows are important and which are not as important, at least. So how would the LLM do that, or how would anyone else do that? Actually, we started by simplifying the task to finding all the flows, and even simplified it further into take this function as a starting point and tell me all the flows that start from this function. And we saw that it's rather a hard task, and for multiple reasons, and I would like to shed light on a few of them. So when we think about a flow, a simplistic version or visualization of that is a list of function calls. Like you have function 1 calling function 2, calling function 3, calling function 4. It's a simplification, of course, but let's work with that. And let's say we want to trace that flow. So we look at the body of function 1, we see it calls function 2. But what happens when you have multiple function 2s in the code, implemented differently with different signatures, for example? How do you disambiguate them? This requires actual understanding of the syntax of the specific programming language. Also, sometimes we do encode things such as import function 2 as function 5. So when I call function 2, what I write is a call to function 5, but under the hood, I'm calling function 2, which is also something you would need to trace. Then there are sometimes injections where you know which function you're calling just on runtime dynamically. This is very common with frameworks such as Spring. And in addition to that, there are so many possible flows that if you want to ask an LLM to do that, you would actually need to set many different queries, and each time try to focus on a particular part of the code base. And still, we found that LLMs had really hard time tracing flows because of these really hard problems. So at this point, we thought, okay, perhaps we should find all the flows and then hand them over to an LLM and ask the LLM to rank the different flows, like which ones are more important. So how do you decide which flows are important? So let's say we provide a flow to an LLM. How would we do that? One option is to say, okay, we have function 1 calling function 2 calling function 3. This is function 1. As you can see, it calls function 2. This is function 2. As you can see, it calls function 3. And send this to an LLM and ask the LLM to rank it. Now, as I said before, this is really simplified. Flows are not linear. Function 1 called function 2, but on some cases, depending on a flag, it might call function 6. And sometimes there is a for loop where it calls function 7 and 8. And it's a way more complex thing. And you can't just send all of that to an LLM together and rely on the LLM to actually trace the flows because of the reasons I explained earlier. So we tried something else. We said, okay, we'll use an agent approach. That is, give the LLM some autonomy to decide which part of the code might be more interesting and ask for more information. That is, we tell the LLM, your goal is to find the most interesting flows. Here are the entry points. When you need more information, let us know. For example, tell us when you need to ask for a definition of a function, we'll provide it with you. And this is like a ping pong with the LLM, because the LLM says, okay, I want this definition now, we're providing a definition. Okay, I want the usages of this function, we're providing the usages. Okay, now I want the definition of this function. It's a long process. And a few things we learned is that first, it's non-deterministic, which means we can send the same prompt, the same query, and get different responses each time, which first, for us as developers or researchers, it makes our lives much harder because we can't iterate and make sure we are improving. It's also really expensive. At the end of the day, it's multiple prompts, and also it's very slow because it's, as I said, a ping pong. You send a query, you get a response. You send a query, you get a response. And perhaps the worst thing is still it doesn't get good results. That is, despite many different attempts and prompt techniques, we saw that the LLM doesn't find the most interesting flows. Sometimes it does find interesting flows. Sometimes it doesn't. It neglects some of the most important flows all the time. And we just saw it's a real hard problem. And in general, I would say generative AI is wonderful at many things, and we use it extensively in Swimm, as we'll describe. But the task of mapping large code bases is just not one of those things where it shines. It is very helpful in other things that we'll talk about later. So I hope you understand how challenging it is to look at a big code base and then try to make sense of it and find, and this is just an example of finding the most important flows. There are, of course, other interesting things. And we saw that using an LLM to it is just not enough on its own. So when we designed our solution to automatically generating code bases and legacy code bases in particular, we had a few guiding principles. One is zero hallucinations. That is, we don't ask the LLM to find things and maybe invent things. We ground everything that we write in actual parts of the code. We also have to be accurate. That is, if you say that function 2 calls function 3, it has to be the right function 3. We have to make sure we understand the connection exactly as it is according to the syntax of the language. It also has to be complete. So we need to understand, for example, all the flows. And then if we decide to show some parts of the flows, mention that we're showing these flows, and maybe we're not showing these flows, or at least know that we chose some flows to show and some are currently hidden unless you ask to see more, but be able to provide the whole information. And also it should be customizable for different companies that want to use the product and perhaps have specific templates where they want their documentation to look like. So to start, we understood we wanted a deterministic approach. That is, given the same input, for example, the same code base, we would provide roughly the same output, or at least the understanding is the same output. For example, given a specific code base, we'll always decide that these flows are the most important flows. For the example of flows, we start by deep static code analysis, which means that for the specific language of the specific repository, we need to really parse every source code file and resolve all the definitions according to the syntax of the specific language. By that, we find all possible flows. Now, a caveat here, this is also a simplification. There are many challenges with that. Just as an example, for a big code base, it's just too much to keep in memory. There are so many permutations of different functions calling different functions. So we needed to find a way to store a subset, but I don't want to dive into that right now. Then we wanted to find ways to rank interesting flows deterministically. That is, not by sending it to a generative AI model and asking it to rank somehow without us understanding the algorithm, but finding very clear heuristics or ways to rank a specific flow so we can iterate on them based on more and more examples we see in our data set till we see that we can, every time we get a repository, find the most interesting flows. And we do that straight from the code by examining the code, how functions call other functions, how many functions they call, and many other things. But everything is done deterministically. Again, this is just an example of flows. A similar case is where we find logical components, and Gilad will show you what that looks like. This is also done deterministically. So our solution has mostly two layers. One layer is language specific. There are many amazing tools for static analysis, static code analysis that are available. Unfortunately, for legacy languages such as COBOL, RPGLE from IBM and other IBM languages, VB6, CAGen, and many other languages, there are just no publicly available tools that do a really good work at analyzing them. And the problem even worsens if you consider that COBOL has more than 300 known dialects in the wild. So we needed to implement specific parsers or plugins for each specific language to make sure we parse it correctly. After that phase, where we parse all the source files, we have our algorithms that are language agnostic, given that in the first step, we were able to analyze and extract all the knowledge we needed. And then we do a bunch of things. So we were able to discover flows and rank them, as I mentioned, also logical components. We also implemented a way to retrieve information that is optimized for code. If you're familiar with RAG, for example, usually AI is used to retrieve textual information. So we had to build something that is really good at finding relevant information from big code bases. It's different than finding information in a big pile of text. And of course, generating documents. So to put that in a schematic view, we start with code. We perform static analysis, deep analysis based on the specific language, given our language plugins. We also analyze documents if they exist for this repository. Some repositories already have some documentation, some don't. These go through another type of analysis. As I mentioned, you need different retrieval mechanisms. All of this information is extracted to an internal knowledge base, which is our internal representation of all the knowledge we have of your code base and your documents. Then we can use this knowledge and run other algorithms to find the most important flows and rank them, to find logical components and rank them, and so on. And this is used to generate documents automatically, as Gilad will show, and also other applications that Gilad will show. Just a short note, when we implemented this, we also had enterprise considerations in place. So I won't dive deep into that now. If you have any questions, feel free to ask them and we'll answer later. But as I said, we want it to be really accurate and make sure we don't miss anything in the documents. It also has to be secure. Really shortly, we don't see the code at any stage. So no code is ever sent to Swimm in this process. It also has to be scalable, of course, and serve different use cases, different personas in the company in different stages, like someone who doesn't know the code and wants an overview versus someone who needs to modernize a specific flow and needs to understand every detail. And Gilad will show that soon. So I hope you understand why it's so challenging to solve this problem of automatically generating documents for legacy code, and also the basics of our approach, which say we perform deep analysis of the code that is deterministic, and we use an LLM towards the end of the process to generate natural language documents. And now Gilad will tell you how we take that and create a solution for organizations.
Thanks. Let's go back and reiterate on what it means to rebuild a mental model of a developer. So we said we need to get an overview of the project. We said we need to have some kind of a code walkthrough with actual examples from the code base, and the ability to dive deeper or see a higher level documentation. So this is the interface for the component discovery stage. It either you know the code or you don't know the code. It can fit. It can help you understand the code base. So at first, like Omer mentioned, we discover the components deterministically. So what you see here is you will always get the same result for the same repository. So we highlight what we think are the most important components in this repository. We don't mind the structure of the code base. It can be a flat list of files. Sometimes our clients stream code from the mainframe into one very large file, or it can be a structured code base with folders. We don't care. We can actually use this step and generate the components we believe are interesting in that code base. If we did not hit, or we did not add everything for that specific code base, you can always add your own modules, and you can remove modules that you're not interested in. And if you don't like this structure or the split, you can always click resuggest, and then we will regenerate and give you another offer of how to structure the table of contents of this repository. So as we said, it was deterministic, but here we're using like an LLM approach because we know some developers, even in the same company, have different opinions of how the project should be structured. So we give you this flexibility to decide how you want to structure the knowledge. After you selected the components, you can click next and then go into the more granular stage when you can actually choose the subcomponents and again regenerate or remove and add your own. So once you have all of these components, we can start to generate the documentation. It takes a while, depending on the size of the repository. We can handle very large repositories, and then it generates the documentation. Like I showed before, it generates around 60% coverage of what you need to know about this repository, but you can play with that, and it's very customizable. So you can decide to have a full coverage, so we will document everything, or a very high level coverage of the repository. So you get this folder structured with actual documentation with one click. And then we have this overview doc that we said to get you oriented in the project. You get a short overview of what it is, even this repository. What are the connections between all of the components that we generated and discovered, and dependencies, imports, flows within different components. And then we give you a short explanation of what is every single part of this repository. There are many documents type to generate. It depends on the language. If it's object-oriented language, so we can generate class docs. If it's COBOL, we can generate program docs. If it's someone who does not need to understand the code very well, maybe we need to generate some product high-level docs. So we have all these type of docs, and users can choose which type of docs they want to generate for the repository. So I show you a lot of customization, and sometimes you don't know the code base, so you don't know what to choose. It also supports the next interface, and then you just get the best suggestions that we came up with. There's also a way to customize documentation and have your own templates and own type of docs if you need them and you have something unique. This is, for example, a class doc. If you have inheritance in your project and you're using an OOP language, then we support inheritance. Again, like we rank flows, we also rank classes. So if we see a class that is being inherited a lot or being used in many places, then we decide to document it. So you can see the class that we decided to talk about, and we show you the complete inheritance tree of that class. And then we start to go over the class. Where is it used? What are the variables and functions and methods this class has? Omer mentioned flow docs. These are very advanced type of docs. We select the flow. You can also select the flow to start with. And then we give you an overview on the flow, how it goes through different components in your repository, and then split it and start a drill down into sections. Again, each section is this walkthrough documentation. So we have the text explaining what we're doing, and then the actual snippets from the code base, and it continue and talk about the entire flow, covering it end to end. Again, inside this flow, we selected a specific path. We can also generate all of the possible paths of that flow. If, for example, you want to modernize and you just need to copy everything this flow is doing into a different language. Logical flows, sometimes called for like the business logic or how the algorithm works. It's not the same as the previous flow documents you saw that just described the call tree or back into front end calls. Here you see the actual logic of a program or a function or even something larger or a component. And this is used, again, to understand all of the edge cases and to know where to start. And again, we select the flow that we think is more interesting. Build tools, kind of a DevOps type of docs. If you find Docker file, Gradle file, Maven file, We know how to generate a document that goes through each and every line and explains what is this line is doing, what is it there for, and more like that. When we talked about with some of our clients about modernization, we saw this engineer product manager duo. They take code, which is the only source of truth they have because they don't have any mockups, they don't have PLDs, so they only have the code base, and they need to know what this code is doing, and they need to be able to modernize it. So they need to decide what are the flows that are going to modernize, how is it affect the product. So the engineer has the access to the code, to the source of truth, and the product manager needs to talk with the engineers and understand what needs to be done or what flows are we going to translate. So we have the same document, but it is generated in two different forms. One is very detailed and technical, and the other is very high level and overview. So this is the same document, but one for the engineer and then for the product reader. And then again, you can see that for the engineer, we include code, and we speak in the technical language of this function calls that function. But for the product manager, we give a more high level of what it is doing, what is the logic behind this program or this function. So if you had documentation before, sometimes you don't, you cover usually very small amount of legacy code bases. Then you can use automatic documentation to cover, let's say, another 60, 70% of your code base. But then it is highly likely that we did not cover everything you want to know and not to the level of details that you need. So then you have other tools to help you to get this additional deep dive and the ability for you to add your own insights. Sometimes when developers dive into a legacy code base to solve a bug, they learn a lot, but they do not leave a trace. So once they solve the bug, they just forget everything and the mental model goes to waste. Here, we will show how we can keep this mental model as a document after they finished. So first, if you want to deep dive, you can always use the chat interface. This is like something that we added to the AutoDocs capability. You can see that the chat interface is also the same format as our documents. So you can ask a question and get a code-coupled answer. The reason it's the same is because if this answer is correct and you know more and you want to add more insights to that, you can create a doc out of it and then have this walkthrough of the answer of the chat and then add your own insights and save it as a document. So different questions, natural language, just like chatting with the generative AI. We also have follow-up questions and an entire chat UX. If you want to add your own insight fast and you have a flow or a flow that you don't understand, you can select snippets of code, add it to a document. I don't understand what this flow is doing, so I go to the code, I add them to the document, and then once I have an entire flow in a document, snippet by snippet in the right order, I can ask Swimm to generate a doc out of it. This doc, I can give it a title. If I don't know, I can leave it as untitled, and then I can give it some instructions on what I want to generate. And the magic starts when you click generate document, and then the engine Omer described that generate the docs kicks in and starts to stream a document about the flow you just selected from the code. So if we did not document that with AutoDocs, you can generate docs on demand for a specific flow. And you can see it's being streamed and you have a new document and you can easily add your own insights. Last but not least, when you add your own insights, the project advances and it might get out of date because someone fixed the bug or changed something in the code. So we track the snippets of code and the tokens of code that you have in the documents. And when the code is changing, for example, I added underscore all to this function, the doc will automatically change. If it's a major change, we will ask you to change it. If it's a minor change, we will do it automatically. And also you can see that if you're in the code, you can always see that there's a document for that feature, and then you can click it and open the document on the side. We want to leave some time for Q&A. So I will let Omer recap, and then we'll answer some of your questions. Omer.
Great. So to quickly recap on everything we talked about, I know it's quite a lot, and I hope you share our enthusiasm with solving this challenge of legacy code. So we started by discussing the pain of legacy code and the mental models that are active when a project is born and gradually decay. So you get to a point where no one understands the code. So we need to rebuild those mental models. We then explained the challenges of dealing with large code bases, and specifically we said that LLMs on their own can't explain a full code base. It's just not the kind of test that LLMs are best at. And then we discussed our solution. Basically, we described the technical underlying principles, saying we want a deterministic approach that relies on deep analysis of the code before we synthesize documents. Then we generate automatic documentation. And as Gilad showed you, you can then follow up with asking questions and adding documents as you go. So we hope you've learned something new about legacy code and different ways to approach this and how we approach it here at Swimm. We're happy to answer any questions now and later. You can reach out to us by email. And if you want to learn more about Swimm, you can also book a demo at our website. And now we'll move to questions. I see we have quite a lot of questions. I will try to answer them one by one. Okay, so first we get a question. How does Swimm perform on unmaintainable spaghetti code? One of the repos we maintain is notoriously hard to maintain, partly because only one person truly understands the overly complex flow. So thank you for the question. It's a great phrasing of this pain of legacy code. And I think this is the pain we're trying to solve, right? This is why we wake up in the morning and work on Swimm. So I think the underlying thing here is when you have spaghetti code, it's really hard to understand what's important and what's not. And it's also hard to trace the connections because everything is intertwined. So I think where we try to help is to first trace all of the interesting parts and then surface them in a way that is clear for developers to understand. That's first. And second, when you have a question about a specific part of the code, you can ask that using the chat interface, and we provide more insights on the go. So I hope that answers the question. I'll be curious to see how this helps you solve this specifically notoriously hard to maintain code base. Okay, so we have another question. I'm wondering what happens when the tool runs into a code bug or defect. Does it skip the doc, call out the error, crash? Interested to know. So when we talk about the automatic documentation generation, there are obviously cases of source code that looks different than what we anticipated. Sometimes code that doesn't compile, say. In this case, we log the fact that we couldn't document this specific part, and we move on to the next part of the code. Okay, so next question, I think, Gilad, you'll take this one. So how did this compare with where Copilot or other assistants are going in explaining legacy code?
Yeah, so that's a good question. And actually, we improve Copilot and those type of chat-based code understanding tools because once you, and we actually integrate organically to those tools. The Swimm documents are being saved in the repository as markdowns. So once you use Copilot, let's say to ask a question, Copilot chat, if you have Copilot Enterprise, which have access to the entire code base, you will get new abilities and new capabilities for Copilot because you have documents in a format that LLMs really like, which is like natural language next to code, and that they entail the complex knowledge of a static analysis that we did. So suddenly, questions like, show me the entire inheritance tree of a specific class can be done using Copilot, and that was not able you won't be able to do that before Swimm or even just auto-generating docs. Now, you all know the garbage in, garbage out concept. So if you have a lot of outdated documentation, those LLMs, they will give you wrong answers or outdated answers. So keeping documents up to date is very, very important. Yeah, I think this is it. Omer, you have anything to add?
No, I think you, it answers the question. If not, please ask another clarifying question. So moving to the next one, what languages are supported? Is each language supported equally, or are there certain features some languages may not yet support? So there is a long list that we maintain of languages we support, and not all languages are supported equally for multiple reasons. One, not all languages have all the concepts. For example, there are languages that support classes and object-oriented programming, and some languages don't, right? And also, as I mentioned, especially for legacy languages, we implemented a lot of those plugins or parsers in-house. So for them, sometimes we haven't yet encountered a specific language, but when we work with an organization that has a language we haven't yet encountered, we create a parser for that as well. Another question, do I need to purchase any subscription to generate automatic documents? Gilad, do you want to take this one?
Yes. This feature is available to our enterprise and enterprise starter plans. So yes, this is a per lines of code subscription. It depends on how much lines of code you generate documentation for.
Okay, next question. How do you handle third-party dependencies used in the repo? Will the generated docs address them when relevant? At what depth? So the rule of thumb here, we document your code. If your code interacts with third parties, we document that interaction. There are some cases where we dive deeper. Say, if you use Django, we don't explain what Django is, but it's so intertwined with your system that we would need to explain a lot about how you work with Django, right? So this is just one example. There are also examples where we document specific types of third-party integrations for very specific tools when they're important. Most of the time, we describe your interaction, and we might provide a link to an external resource explaining about the third party, because the third party is not yours, it's not for us to document. Can you give a quick demo of showing it to work in a sample legacy code base? Gilad?
Yeah, actually, some of the documents you just saw are COBOL repositories, specifically an open source one called Kelo. And yeah, this was an example of legacy code base.
Right, Kelo is implemented in COBOL 85. As far as we know, the largest COBOL code base that's available is open source. So most of the examples you saw today are actually generated on this one. Is there a level you can submit to the LLM of how interesting a flow is that the AI should focus on? So actually, from all of our experiments, we saw that the LLM is not really adept at deciding whether a flow is interesting. It's a really hard question to ask, is this flow interesting? What we can do is decide deterministically that a flow is interesting and then provide the LLM the flow, explaining which parts are more interesting. And then, yes, the LLM knows to focus on those parts that we identified as interesting. Is this capability available in the latest release? So yes, but we, as Gilad mentioned, this is also for enterprise clients. So you would need to be in our enterprise tier. If you're interested in that, let us know. Okay, related to something was related to code assistant question. Oh, do you mean the chat interface? I'm not sure I understood this correctly. Sorry. So if I didn't understand, please ask again. How does this perform on front-end code bases? Gilad, you want to take this one?
Yeah, as a front-end developer.
Yes.
It is the same. We can get the flows depending on the framework you're using, but it works rather well with front-end code bases. Flows are flows in code, and static analysis works very well for that as well.
I said we focused a lot on legacy languages because many of the organizations we talked with felt the most pain there. But obviously, lots of organizations use front end, and the main front end technologies or frameworks are so widely used that organizations want documents for them. So we have worked with many different code bases, including front end.
Okay.
Right. Okay, I
So,
think we
yeah.
were able to answer all the questions sent over the chat. Thank you so much, everyone who joined. We hope you enjoyed this session and learned from it, and we'll be happy to be in touch later. So feel free to email us with questions or thoughts or feedback. We'll be happy to hear from you. Thank you, everyone,
Thank you very
and
much.
enjoy learning more about legacy code.